Hello all. This video is going to be for chapter 2 lesson 5, which is about algebraic proofs. Now you might be wondering, why is an algebra lesson in middle of a geometry lesson in geometry chapter? Well, that's because they just wanted to know how do you prove, or how do you show the justification for each step you're solving. So rather than skipping to geometric proof, it's always easier to start with algebra, because I know many of your favorite is algebra than geometry. So it's going to be an easy way for you to understand the later on lessons. So first of all, to start with the lesson, we need to know what is a proof. A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Well, you know what proofs are. If you do something, we definitely need a proof. So every time whatever happens, we need to keep a proof so that we can prove ourselves that this thing happened. So similarly in math also, we do use proofs to show this is how we arrived at the answer. As you know, math always works out with logic, so definitely we need to keep the proofs. So we need to know the proofs. Even if someone asks, so why did you do this, why did you solve it like this, we need to have our proof and say this is why we solved it like this. So to start with, these are the kind of properties we are going to be using throughout this chapter, which is about it. They are easy, already you know all of them. Even then, in proper way, let's learn what are these properties. So the first one to start with is addition property of equality. It's nothing, just when you add something, you say that's addition property of equality. So you say 2 plus 3 equals 5. So someone might ask, why did you say 2 plus 3 is 5? That's because of the addition property of equality. Then similarly, subtraction is when you subtract two numbers. Multiplication is whenever you do a multiplication operation, when you solve an equation, that's called multiplication property of equality. Division property of equality is also the same. So basically, the first four are the most used ones during justification of algebraic questions. So it's nothing. Whenever you do an addition operation, we say it's addition property. Whenever we do subtraction, we say it's subtraction property. Similarly for the other two also. So these are the, now definitely you know they will not prove the properties with numbers, rather they have given you variables. So if A equals B, then A plus C equals B plus C. Well, do not confuse yourself for now with these. When we go on with the questions, you will understand what these properties are, right? So I think this is these are the only four properties which are a bit new to you, which is reflexive property of equality. What is reflexive property of equality? When both sides of the equation have the same number. So sometimes when you solve equations, you will get statements like this: 1 equals 1. Definitely you will get, mostly we get 0 equals 0. So when you get something like this, that means we are using reflexive property of equality. Similarly, here we have symmetric property of equality. What does that mean? If A equals B, then B equals A. That's how this looks. If X equals 2, I can also say 2 equals X. This is symmetric property of equality, just like symmetry, right? Uh, and reflection is like how you see the mirror image. So it's the same with both sides of the equation, but here if A equals 4, the next one is going to be 4 equals A, which means the same. That's called symmetric property of equality. What is transitive property of equality? If A equals B and B equals C, then A equals C. Let me explain that with numbers for you. Say for example, if the value of A was 3, if I say A equals B, then the value of B is also 3, right? Now, if I would say B equals C, that means what is the value of C going to be? It is also going to be 3. So automatically, I could even say A equals C because both of them have the same values. This is called transitive property of equality. Okay, so that's when three variables have the same value. We could say the first one is equal to the last one. What is substitution property of equality? Nothing. Remember some of the questions which you solved in the first chapter of geometry algebra had find the value of x plus y when x equals 3 and y equals 5. So what did you do? You had to replace the numbers, right? This replacing of numbers in place of variables is called as substitution. You must have heard me using this word very often because these are mathematical words we use most commonly. Substitute. So substitute means replace the numbers in place of letters or replace letters in place of numbers. That's called substitution property. So these are the 8 properties you're going to be using to prove algebraic questions. And also one more thing is the distributive property. Distributive property, all of you know, if you have a question like this, what are you going to do? You are going to multiply each term with the number inside. So whenever you multiply the numbers inside the parenthesis, this is called as the distributive property. You know this, but the only thing is you do not know them in terms of properties. That's all, because you know if you have something like this, you need to multiply each term inside the parenthesis, but you did not know till now that it was distributive property. This is called distributive property. That's all. Now similarly, these were for the properties of equality. Now let me show you what are the properties of congruence. Now what is congruence? See this, the difference between equal and congruence is numbers are equal and figures are congruent. Now if they ask you, give you 2 figures and they ask you to show the proof, which we have later on, I'll show you, that's called congruence, because this symbol is used in geometry. We never use this in algebra because this symbol means congruence, which also means equal, right? So what is the reflexive property of congruence? You can see reflexive property means EF is congruent to EF. So similar to the reflexive property of equality. Reflexive property of equality says A equals A, but reflexive property of congruence say EF is congruent to EF. So only difference is there it was equal, here it is congruent, and here we talk about figures, there we talk about numbers. That's all. Similarly, symmetric property, if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. It's the same. What is transitive property? Similar to the property which we learned of transitive property of equality. If figure A is congruent to figure B, then and figure B is congruent to figure C, then figure A is of course congruent to figure C. Just like this example here, I explained it with equal sign here because they're talking about figures. That's about transitive property of congruence. Now there are 2 more properties which I would like to explain you. One is the segment addition postulate. What is the segment addition postulate? They are 2 when you add 2 segments, you know that these are line segments. So when you add 2 segments, this is called segment addition postulate. So you will find questions like this where they have asked you to find the length or the distance. Now it's not x and y, you will have 3x plus 5. This I just gave an example, that's all. So when you are adding these 2 segments, this is called as segment addition postulate. Similarly, we also have angle addition postulate. When we add segments, we say segment addition postulate. Similarly, when we add angles, we say it is angle addition postulate. That's all the difference is about. So if I say this is A and this is B, this is C and this is D. So I can say angle ABC plus angle CBD is equal to angle ABD. So when you add 2 angles and show a statement, that's called angle addition postulate. So I think it's easy if you understand and if you write down all these postulates and the properties in your diary or a paper, wherever you are writing, it's easy for you to revise. Right, so let's get started with this question. Let me show you, and once I start solving it, definitely you will see how easy it is. So first let's solve this normally how we would solve it. Now there are 2 ways you can solve this. One is by multiplying each term inside the parenthesis, right? So when you're multiplying each term inside the parenthesis, that's called distributive property. But here rather than making it difficult in that way, what I would like to do is I'm going to divide this that side with negative 1 over 5. Why am I going to divide? Because you know it is 1 divided by 1 over 5 multiplied by a plus 10. So which means to remove this 1 over 5, I'm going to do the opposite. Right? So the first thing, always I need to write down the same question. This is also a very important step. Always we write the question and then we write the justification step as given, because that's the question. So we say this is given. Okay, so the next part is I'm going to solve it. So when you're solving, what am I going to do? I'm going to move the 1 over 5 to the other side. So it becomes negative 3 divided by 1 over 5. Right? Now what did I do here? I have simplified, I have divided. So which property do you think I'm going to write here? I need to say it as division property of equality, because we are dealing with numbers now. So we say it's equality. So because I'm dividing, I say it's division property of equality. So let me solve this now. Now when I solve this, you know that you cannot divide a fraction, rather you need to flip this, right? Now when you are justifying any statement, I cannot say this as multiplication property of equality. No, because I'm not multiplying for the question, I'm only solving this. So you could say this as simplify, or you can, if we call it simplify, whenever there is a solving step, we call it as simplify. So this is going to be negative 15 over 1, which is going to be negative 15, right? Negative 3 multiplied by 5 is negative 15. 1 multiply 1 is 1. So if you would solve that, that will be simplify again, because I just solved it. I did not do anything else. What's the next step you are going to do? You are going to subtract positive, you are going to move the plus 10 to the other side. So what happens is it becomes again minus 10. Right? So what did I do now here? I have subtracted. So I am using subtraction property of equality. So whatever you do, that's what the property becomes. So here now I'm going to say A equals negative 15 minus negative 10. So it becomes A is equal to negative 25. What did I just do? I just solved it. So when you solve it, you say that you have simplified. So that's the end of the question. A equals negative 25 with all the justification steps. Isn't that easy? It's easy. Right, so let's try this next question. What's the first thing I'm going to do? I will be simplifying. First let me write down the question and say it is given, because that's also an important step. So t plus 6.5 minus 3t equal, oops, wait, it's equal, right? 3t minus 1.3. So I give the justification step as given. Okay, now what's the next thing I'm going to do? Now because we are doing justification, we are only going to do one thing at a time. Now one thing means either you bring the 3t to this side, or you move the 6.5 to that side. You can only do one thing, not two things at once, right? So first let me move the t to this side. So that becomes t minus 3t plus 6.5 equals negative 1.3. So what did we just do here? What happened to the t and the 3t? It became negative. So that means what property are we using here? We are using subtraction property of equality. Right? So the next one, what am I going to do now? I will not move this unless I solve this. I need to solve this. So how much is t minus 3t? That's going to give you a negative 2t. So what did I do in this step? Did I move anything? I did not move anything. I only solved it. So that's called as simplify. Whenever you solve something, you say it is simplify. Now I'm going to do the next thing. What am I going to do? I'll move this to the other side. So what happens is this step becomes negative 2t equals negative 1.3 minus 6.5. Because it's positive on this side, it becomes negative here. What did we just do? We just subtracted again. So again it becomes subtraction property of equality, right? Now, what's the next step I'm going to do? I'm only going to solve this. So whenever you solve it first. So this is going to give you negative, negative, which means you're going to add them. So that's going to give you a 7.8 and negative 1. So what did we do? We solved, and that's called as simplify. What's the next thing we are going to do? We are going to divide this with negative 2. So t equals negative 7.8 divided by negative 2. So what property are we going to give here? What did we do here? We divided. So it's going to be division property of equality. So when you solve this, you're going to get, you have two negatives, so you could cancel that out. So all what is left for you is t equals 3.9. 7.8 divided by 2 is going to give you 3.9. So this is called as simplify again because we just solved it. That's all. So what you do, you write. That's called justification. That's all. That's nothing difficult. If you're subtracting something, you say it's subtraction property of equality. If you're dividing something, you say it's division property of equality. If you're solving something, you say it's simplify. It's as simple as that, how to write justification steps. We have already done this, only we have not given the reason why we did it. That's all. Okay, let's move to the next question. Now there's a problem solving question where they say the formula for perimeter of a rectangle with length L and width W is P equals 2L plus W. Find the length of the rectangle shown here. If the perimeter is 9.5 feet, solve the equation for L and justify each step. Okay, so you have to do two things here, I think. Yes, so they have given already the perimeter. So we have to solve the equation for L, means we have to find the length. Okay. So first let's write the formula. So the formula given for us is P equals 2L plus W. What's the reason we are going to give for this? Given, because that's the question and that's given. Okay, now next thing, I'm going to replace these values with the numbers. So here I already have the length as L, we have to find that. The width is 1/4 and the perimeter is given to be 9.5. So I'm going to write the numbers in place of the variables. So this is going to be 2L plus, what's the width? 1/4. What did I just do? What kind of justification are we going to give here? I replaced the numbers. So what is the replacing called? It's called as substitution. So substitution property of equality is the first justification. The next thing, I'm going to solve each of them. Right? Now there are many ways you can use to solve this. So let me show you how to solve. I think using the easy way will be better, right? So here I can see that it is multiply, 2 multiplied by L plus 1/4. So to remove this number, I am going to divide it. So to divide it, I'm going to say 9.5 divided by 2 is going to be equal to L plus 1/4. So what did we do here? We did division property of equality. Okay, so let's solve this. To solve this, what you need to do is you need to change this into a mixed number and flip the question. I mean the fraction. So this is going to be 2 9s are 18 plus 1 is 19. So that's going to be 19/2 multiplied by 1/2 because KCF, we cannot divide a fraction, so we are multiplying it, right? Okay, so the next thing is equal to L plus 1/4. Now this is called simplifying. We are not doing anything. We are only solving still the question. So when you simplify, you're going to get 19/2, which is going to give you what? 19/2 is going to give you 9.5. Okay. Again, no. 19 over 4, because you have to divide 2 2s are 4. So this is going to give you 4 4s are 16, right? 3 over 4. So this is going to be 4 3 over 4 equals L plus 1 over 4, and still I have only simplified. I did not solve anything still now. I'm still solving the fraction. So again, this step is also called simplify. Now let's move to the next step. Now what's the next step? Move the 1 over 4 to the other side, right? So 4 3 over 4 minus 1 over 4 is going to be equal to L. What did we do here? We have subtracted. So subtraction property of equality. Okay, then just you need to solve it. 4 minus 1 is 3, and this is going to give you, so 4 minus 1 is a 3. 3 minus 1 is going to be 2 over 4, which when you simplify this, you are going to divide that with 2, so that's going to give you a half. So 3 half is going to be equal to L, and I have just solved it, which means it is simplified. So finally the answer is going to be L is going to be equal to 3.5. Now you can say this as there is a property which we use to say that both sides of the equation means the same. Let me go back to the properties and show you. This is called symmetric property of equality. So we have to write here, this is symmetric property of equality, because we got the L on the other side, but it's always preferable to keep the variable in front. Now there is also another method to do this. You have to solve, multiply 2 with L and 2 with 1.5, 1/4, and then say it's distributive property, but I felt that way will be, it's going to be a way bit longer, so this is the easiest way you could solve this question. Go through it again. If you have not understood, pause the video, just observe what has been done, then definitely you will understand what is to be done, and try to do it by yourself again. You will get the answer, but you have to. Right, so let's move to the next question. Okay, here you just need to write the justification, that's all. Now when you're writing justification, there is one thing to be noted. I will show you what you need to do. Now as soon as you see, you can say that they are adding segments. Okay, so what did they say? Hj, that's the complete length, Hj is equal to Hi plus Ij. So they're adding these two parts. So what is this thing called which they're doing? This, they're adding segments. So this is called the segment addition postulate. I explained this in the beginning of the lesson. Okay, what's the next thing they did? Hj they replaced with 7x minus 3, and Hi they replaced with 2x plus 6, and Ij with 3x minus 6. 3x minus 3. What did they do? They have replaced. So what is replacing called as? Substitution. So it's called as substitution property of equality. What's the next thing they have done? See here very carefully. This 7x minus 3 remains the same, but 2x and 3x became 5x. 6 and 3 became 3. How did that happen? What did they do? They have solved it. 2x plus 3x is 5. 6 minus 3 is 3. So they have solved it, which is called as simplify. What's the next thing? They have moved, see, you can see very well. Here there is a negative 3 and a positive 3. Then suddenly it became 6. How did that happen? Because they have moved the negative 3 to this side, and they have already added and given us the answer. So what have they done? They have added 3 plus 3. Because they have already given us the answer, that's called as addition property of equality. Now here they are not showing each and every step, just like how we did. They're not showing you each and every step. Here they're skipping the simplifying step, and they want you to write only the important part. What did they do next? 7x equals 5x became 2x. How did that happen? Definitely they moved the 5x to that side, so it became a minus. So when you use minus, that's called as subtraction property of equality. and then 2x equals 6 became x equals 3. Whoa, what happened there? They moved the 2 to divided by 2, so that's called as division property of equality. So when they have given you the solving and they ask you to write the justification steps, you need to figure out what happened and then write the property. Well, it needs a bit of observation and very careful looking into the steps to see what happened. But once you have mastered the art of looking at a question carefully, that becomes super easy to do it. So let's move to the next question. This is an easy one. Identify the property that justifies each statement. So they want you to write the properties. M equals N, so N equals M. Just now we did this. What's this called? This is called symmetric property of equality. Because if x equals 2, 2 equals x. Just now I think we did here, see, symmetric property. 3.5 equals L, 3.5 equals L, L equals 3.5. It means the same. Now angle ABC is congruent to angle ABC. This is reflexive property of congruence, because reflexive means it's the same. Reflexive property of, you cannot write equality because the symbol here is different. It's called as reflexive property of congruence. KL is congruent to LK. What kind of property is this? They just flip the letters. So this is again reflexive property of equality, congruence, because they did not say KL equals anything else. If they would have said KL equals MR, then it will be symmetric, but here it means the same. KL and LK, you know, a line can be read in two different ways. So this is again reflexive property of equality, congruence. So do not worry if the letters are changed. Only make sure that this kind of questions should not be given. KL and LK means the same, so it doesn't matter, because if it's a line, if KL, this is KL, if there's a line segment, KL and LK means the same line they're talking about. Okay, P equals Q and Q equals -1. So P equals -1. What kind of property is this? First of all, it's something to do with equality, because they are numbers. So P equals Q and Q equals -1. So what does that mean? Remember, we learned something like this. Then P equals -1. What is that? This is called transitive property of congruence. Transitive property of, not congruence, equality. Sorry for that, it is equality. So once you know the properties, it's very easy to identify what kind of properties they have used. Only go through the properties and keep those in mind. Well, the properties are not difficult at all. So hopefully you have understood the lesson. Do comment and let me know whether you understood the lesson or whether you have got the answers right. So again, all the advice is keep practicing and keep looking, observing the question before you do these kinds of solve these kinds of questions. So till we meet again, keep practicing.